So here, how do you calculate percentiles? You write the data frame name, you write the column name, call the function. What's the function name? What is the function name?
Quantile.
Quantile. And then you mention that as quantile is 0. 0 means 0 percentile. 0.1 means 10 percentile. 0.2 means 20 percentile. So whatever you mention here, that will be given to you. So basically the output will have two columns. What is the first column? First column is percentile column. Whichever percentile that you mention, that will be given to you. The second column is variable value. What is the variable here? Capital gain value. 50, 60, 70. 1 means 100 percentile, which is maximum value. How do you get, let's say, 75 percentile? If I want to get 75 percentile, how do you get that?
0.75.
You simply mention 0.75, then you will get the 75 percentile. That means what Python is going to do is, as soon as you use this quantile function, whatever theory that we have seen, arrange the data, divide the data into pieces, and then find out what is that value in capital gain, where below it is 10%, above it is 90%, that will be given to you. Okay. Have you understood this piece of code, all of you? Please confirm that. Data frame name, column name, dot quantile, mention whatever percentiles that you want. Go ahead, go back to your code file. Go back to your code file. Execute this code. Let me know once you have the data. We will discuss the output. Once you have the data, we'll discuss the output here.
It's going 100%.
Are you ready with the output? Are you ready to discuss? Let's wait for others.
Yes, sir.
Now, tell me what's the 0 percentile value?
0.
0.
Sir.
So that means when we did the analysis, when Python has calculated using capital gain, it has arranged the data and 0 percentile happens to be 0. So what do we call? So what is our inference out of it? Tell me, what do you write out of this? Minimum value of capital gain is 0. Are there any negative values in capital gain?
No, sir.
Why are you so sure? How can you be so sure? If there would have been any negative values, then 0 percentile would have been that value, isn't it?
Negative.
Yeah, some negative value. What is the 10th percentile value?
0.
0.1.
0.1 or 0?
0.
0.1.
क्या बोल रहा है यार? Are you getting the output?
0, sir.
0, sir.
0, sir.
10th percentile is 0. Are you with me, everyone? Carefully.
Yes,
Anybody got 0.1? Check that once again. 10th percentile. First column is what? Percentile. Second column is what? Value. 10th percentile is 0. That means, what can we say? 10% of the values in the capital gain are zeros only. Is that a right statement?
Yes, sir.
10% of the values in the capital gain are zeros only. Now standing here, can we say that remaining whole 90% are greater than 0?
Yes.
No, sir.
Yes.
बिना देख के yes sir कैसे बता सकते हैं? Can I say all these are greater than 0 for sure?
No,
If I
sir.
see it or don't see it, I don't care. Can we say like that? Can we assume like that? Think
No.
about it.
Yes, sir.
I have seen the data only in 10 percentile. I would say 10% of the data is greater than 0, or 10% of the data in capital gain is actually 0. Remaining 90% may be greater than 0, but I'm not sure. Are you with me? Why am I saying not sure? Because I haven't seen that.
I have seen the data.
Yeah, it can be anything. What is the 20 percentile value?
0.
0.
Is also 0. Tell me, what is your first statement that you will write if your 20 percentile value is also coming to be 0? What do you write? Tell me, first statement would be
20% of the capital gain is 0.
20% of the capital gain is actually 0. I have seen
0.
it with my own eyes. How about the remaining 80%? Can I say remaining 80% will be greater than 0?
Yes,
sir.
Not sure.
No,
No,
sir.
no.
Absolutely sure. You have seen
Not sure.
everything?
not sure.
Not sure. See, you have seen 20% of the data. You can only make comments on the 20% of the data. Similarly, you keep on going like this. What is the 80 percentile value? 80 percentile value.
0.
80 percentile value is also 0.
0.
Tell me, what is your first statement out of that?
80%
of the capital gain is
80% of capital gain is 0. How about the remaining 20%? Greater than 0. Are you absolutely sure or not sure?
Not sure.
Not
Not
sure.
I have seen only 80% of the data. I'm not sure about the remaining 20%. I'm sorry. Not sure. What is 90 percentile value?
0.
90 percentile value is also 0. 90% of capital gain is 0. How about remaining 10% of the capital gain? Greater than 0. For sure or not sure?
Not sure.
Not sure.
You have seen the data until what?
90%.
90%. Can you comment on 90% of the data?
Yes,
Yes.
sir.
Have you
Yes,
seen
sir.
the remaining 10% of the data?
No, sir.
Can we comment on it surely?
Not sure.
Why are you so sure about 90% of the data? Have you really seen it? Have you seen 0%, 20, 30, 40, 50, 60? Are you absolutely sure that 90% of the data is actually 0?
Yes.
Yeah? Or maybe less than or equal to 0, which is anyway, generally the way we write it is less than or equal to 0, which covers both 0 and less than. Let's say if this happens to be 20, we will say less than or equal to 20, something like that. But here it is 0. So what's the 100 percentile maximum value here?
99,999.
So is it fair to conclude? Can I conclude 90% of capital gain is actually taking zeros? 10% of capital gain is taking values greater than 0. Can I give a conclusion like that? Is that a fair
Yes, sir.
conclusion?
Yes.
No, sir.
The full 10%, full 10% is going greater than 0. 100% guaranteed. Can you give me that guarantee?
No, sir.
Can it even happen that 99% are zeros? Only 1% is greater than 0, but the maximum value is 99999. Can this also happen?
Yes, sir. Yes.
If that happens, what is 90 percentile in this scenario? What is 90 percentile? If 99% are 0,
So
0.
0.
100 percentile will be this. So we cannot conclude that remaining whole 10% is greater than 0. Are you with me? Maybe
Yes, sir.
95% are zeros. Only 5% are greater than 0. Maybe 98% are zeros. Only 2% are greater than 0. Are you with me, everyone?
Yes, sir.
Yes, sir.
Without looking at this 10%, can we really conclude anything from there?
No, sir.
What do we need to do? We need to drill down. Yes or no? We need to drill down and find out 91 percentile, 92 percentile, 93 percentile. Until 100 percentile, we have to drill down. Yes or no? Tell me, how do you fetch 91 percentile, 92, 93, all those percentiles?
0.91.
So you will take the same code. What's the modification? 0.9
0.91,
stands for
0.9.
90 percentile. 0.91 stands for 91,
91%.
92,
92,
93.
93, 94.
Yes or no?
Yes, sir.
This modification, you can do it. Now what
Yes,
you're
sir.
going to do is write that code and tell me. Don't paste the answer in the chat window. You have to analyze that output. Tell me what percent of capital gain is exactly 0 and what percent of capital gain is greater than 0. So put a 2-word answer in the chat window, which indicates the first one is what percent of the capital gain is exactly 0? Is it 90 or 95 or 98 or 99? And what percent is greater than 0? Is it 1%, 2% or 5% or 10%? Give me a 2-word answer in the chat window by writing that code, drilling down, analyzing it, and finally giving me this result. Give me a 2-word answer. First one, second one, both of them in one message. You give me what percent are 0, what percent are greater than 0. What percent of the values are 0? Overall 100%. Suraj 91.8, 99. बाकी 1% कहाँ पे गया था? So we would say 8 plus 2, 10% ही बता रहे हो. बाकी 90% कहाँ गया? How much percent of the data is a 0? 91% of the data is 0. Yes or no?
Sir,
92.
92, sir. 92% of the
92
sir.
percentile
0.
कितना है?
91 and 9.
92 percentile 1458. I can see that. Yes or no? Check that out. Confidently, how much percent is 0?
91.
91 or not? Tell
91,
me.
sir.
Can we
Yes,
say
sir.
that 91? Are you just confusing because we missed these? Let me put all these then. If I keep all these, then you would be saying until what percent there are zeros? 10, 20, 30, 40, until 91% of the
91.
data is 0. How much is remaining?
9,
If
9%.
91% is 0, remaining 9% is greater than 0. In fact, we can drill down further and say some 91 point something, some 8 point
Yes.
something, but we don't need to go that much granularity because anyway we are going into 100 percentile, which is like 100 pieces of granularity, which will be fine. 91% of the data is 0, 9% of the data is greater than 0. Have you understood this code, all of you? Especially a lot of people came with coding concerns. I'm asking this multiple times. Have you understood this code? Then only we'll proceed.
Yes, sir.
Not very difficult, isn't it? This one is not very difficult. It's just calling a simple function and passing out whatever. Like as a data scientist, your coding is second priority, isn't it? Because already ready-made function is there. Analysis is the first priority. The same code you will use again and again in every project. Every time you're doing percentiles, are you going to write a different coding logic? You have worked on percentiles 30 times. Are you going to write different 30%, 30 codes, different codes? Or are you going to reuse the same code? This coding that we do in data science is very different from the coding that we do in software. If you're developing some software, every time you write a different code. Unnecessarily, people get confused this coding with software coding. They think that I'm not confident. Not really. You just need to recall the same thing again and again. Analysis is the most important priority factor here. Yeah. Now
Yes.
we go to our client. We tell the client that you know what, we have drilled down capital gain. We looked at its complete distribution. What is distribution? From its minimum value, which is 0 percentile, to its maximum value, which is 100 percentile. We have looked at its complete distribution. What do you mean by distribution? What are all the values taken by capital gain? Where is the whole concentration of the variable? Haven't we really seen completely capital gain from 0 percentile minimum value to the maximum value? Completely drilled down maximum gain, capital gain. We found out that 91% of the times capital gain is actually 0. 9% of the capital, 9% of the times it is going above 0. That's what we found out. Then our client, our business partner, probably sitting in US or UK, they are giving us their business side insights. Yes, capital gain. What should happen is, actually from our business knowledge, we can tell you that capital gain has to be always 0. That's right. If it is less than 0, greater than 0, now that is erroneous, or there must be called as outliers. Any capital gain value less than 0 or greater than 0 should be called as outliers. It has to be always 0. If that is the case, how much of the data in capital gain is clean? How much of the data is actually outliers?
9%.
91% data is clean.
91% of the data is clean to use. 9% of the data is outliers. When you're deciding outliers, it's not just the statistical distribution. It's not just the percentile distribution that you should look at. There are two factors. Factor number one is percentile distribution. Of course, you will see that to detect the outliers. Factor number two is business context. A lot of people miss this business context. Outliers are not solely decided based on percentiles. Business context. For example, if you take age of 85, same variable age, same value 85. In different contexts, sometimes it will be called as outlier, sometimes it's called as non-outlier. Let me give you an example. Context one. You are handling loans portfolio, personal loan portfolio. Age of 85. Is it an outlier or regular number? Chalta hai? Age of 85. Do you think such
Outlier.
customers will be found in
Outlier,
personal
sir.
loan portfolio?
They're outliers.
Definitely, this is an outlier. Age of 85 in savings bank account portfolio. Age of 85. Is it very high, or can a person have age 85 still he can have a savings bank account? Is it odd? So can I say age, same variable, same value? In some cases, outlier, in some cases, non-outlier. Is it fair to say outlier should not be solely decided based on percentile values? You should always see the business context as well. Are you with me, everyone?
Yes, sir.
Business context
Yes.
will decide and tell us sometimes what are outliers, what are not outliers. That's how you detect outliers. By using the percentile distribution, you will get to know where is the whole concentration of the population and are there any values that are very far away from the concentration of the population. To get a better understanding of this, what we will do is we will try to take one more example. This time we will take some credit risk data. The original objective of this credit risk data is to build a credit risk model that will predict whether a customer is risky or non-risky eventually. But here, are we really building a model right now sitting in this classroom? What is our objective right now?
Detect the outliers.
Detecting the
So
outliers.
basically, we would like to go through each and every variable. We would like to detect the outliers. Why should we do that before going into the model building? I already have the data. Why can't I simply build a credit risk model?
Data cleaning.
If there are outliers in the data, do you think the results that will come out of that will be correct?
No, sir.
So we should detect the outliers, isn't it? One of the variable here is monthly utilization percentage. One of the variable is monthly utilization percentage. For example, two customers are there, customer A, customer B. Customer A has a credit limit of 1 lakh. This example you have already seen. Where we have used this example in Tableau, isn't it?
Tableau.
Company A, company B, two customers. Both of them have the same credit limit. Sorry, not company A, customer A, customer B. Customer A is utilizing 95,000 every month. So his utilization percentage will come down to
95%.
95%, 0.95. Customer B is utilizing, let's say 12,000. His utilization percentage will come down to
0.12.
0.12. Who is risky? Is it A or B?
Sir, A.
Why A is risky? If A suddenly absconds, disappears, how much will be the loss that you will make?
95,000.
95,000. If B absconds, how much will be the loss?
12,000.
12,000.
Who's risky? Where do you make higher loss? Now tell me, what is the max value? What is the min value that this monthly utilization? First of all, tell me what is the minimum value this monthly utilization percentage can take? Minimum value.
0.
Minimum value is 0. That means if you're not at all using the card, it will be 0. Can it be negative? If
No,
you're
sir.
not
No,
using
sir.
the card, can it get into negative values or anything? No.
No, sir.
Maximum value is how much?
1.
1.
1 lakh is the credit limit. Since this is monthly utilization percentage, you're using 1 lakh out of 1 lakh. That will be 100%, which is 1. 0 means 0%, 1 means 100%. So the limits are 0 to 100 or 0 to 1. 0 to 1 are the limits. Can the utilization be more than 100%? I gave you a card with 1 lakh limit. Can you swipe it for 3 lakhs, 4 lakhs, 5
No,
lakhs?
sir.
No, sir.
Will the system allow? You're going to get an error, right? The value that you entered is more than the credit limit, or you have exhausted the limit, something like that. The system won't allow. 0 to 1 are the limits. But are you really sure that in this data? Anyway, we got it from bureau. Every value will be definitely between 0 and 1. Bureau hai, sahi to diya hoga. Can we think like that?
No,
No, we have to check that. We have to see anything between 0 and 1 is clean data. Anything less than 0 can happen. That is issue. Anything greater than 1 can happen. That is issue. These are the outliers. Outliers sometimes doesn't necessarily mean they are very, very far away. Even 1.001 is an outlier. Do you agree? 1
Yes,
lakh,
sir.
1000 is also an outlier here. Why? Is it possible business wise?
No, sir.
That's not possible. So what I want you to do right now is import that credit risk data, take this monthly utilization, look at the quantiles and tell me what percent of the data is clean. Clean means 0 to 1. What percent of the data is outlier? Two types, less than 0, greater than 1. Is it like 90% versus 10%? Is it like 95% versus 5%? Is it like 93% versus 7%? Tell me what is the right answer. Go ahead, do everything on your own. You should be able to do that now. What is 0 percentile? 0 percentile is coming out to be 0.
0.
Yeah. So what's the minimum value?
0.
0.
0.
Minimum value is 0. Okay. So are there any low side outliers? Are there any values less than 0?
No, sir.
No. This side we are safe. Minimum value itself is 0. 10 percentile fine, 20 fine, 30 fine, 40, 50, 60, until 90 percentile, everything is fine.
Yes, sir.
But what's the 100 percentile value?
50,000.
50,000.
So somebody has a credit limit of 1 lakh. He has swiped for 507 crores. 1 lakh credit limit. Can you swipe for 507 crores? Impossible, isn't it? But still the number is there in the data. Do you think these kind of outliers will have to have any effect on the final analysis, or they have huge impact? They will turn our analysis upside down. Yes or no? Can we safely take this data? Not at all. So is it fair to conclude that 90% is clean? The whole rest of the 10% is absolutely having outliers without any doubt, very, very confidently. Can we say like that?
No, sir.
Can I totally take this rest of the 10% of the data is having data greater than 0? For sure.
No, sir.
No, sir.
90% is clean. That is the right statement. But 10% outliers? No. What we should do now? Tell me.
Again, segregate the 10%.
91, 92, 93.
Yep.
Write it
91.
down.
Like you cannot assume that rest all 10% is having issues. Yes or no? 93, 94, 95, 96, 97, 98, 99, etc. until 100%. Do that now and tell me what percent of the data is 0, what percent of the data is anyway in between, how much of the data is clean, which is between 0 to 1, how much of the data is greater than 1, outlier data.
97% is clean.
97% is clean. How much is greater than 1? Roughly
3%.
Are there any other answers? Maybe correct, may not be correct. Always first answer may not be correct answer. Any other answers? Anybody else that you think? 99% are clean, 1% are having
1% is.
maybe correct, may not be correct. Always second answer also may not be always correct. Give me your own answer, everybody. Form your own opinion. Do your own analysis. According to you, what percent of the data is clean? What percent of the data is having issues? Let us see.
1% of the data is
That's right, yeah. Let us see. 90% clean, 91 fine, 92 fine. Can the credit monthly utilization percentage be 100%? Is it possible?
Yes.
You have 1
Yes,
lakh
sir.
credit limit, you swipe for full 1 lakh. Is it possible? Possibility is there?
Yes, sir.
So 97% until 97, it is fine. 98% is 1.006, which means 1 lakh is the credit limit. You have swiped for 1 lakh 6,000. Is that possible?
No, sir.
No, sir.
Tell me once again, all of you. 1 lakh is the credit limit. Somebody has swiped for 1 lakh 6,000. Is that possible?
No, sir.
So tell me what percent of the data is clean? What percent of the data is having issues?
Sir,
97%.
97% of the data is clean. Remaining 3% are having issues. Outlier doesn't always mean very, very far away value. Outliers are not just decided based on these percentile values. Tell me, outliers are decided based on 2 factors. What are they?
Sir, the percentile distribution and business context.
Business context. From the business context, can I call this as outlier?
Yes, sir.
Agree with me, everyone. 97% of the data is clean. 3% of the data is outlier, maybe 97 point something, maybe 97.5, maybe 2.5, something like that. But we don't need to go to that level. 97 and 3. Are you convinced with this? Especially those who have different answers. Now, are you convinced with the logic?
Yes, sir.
Yes, sir.
Yeah, makes sense.
Sure.
Sir, I have a question.
Yeah, please go ahead.
So, like this data which is coming, like it is in percentage or it's value, like how will know that?
Which variable is that? It depends on the variable. Which variable is this? Monthly utilization percentage, right?
Okay. Like I didn't know, like from without seeing the data, how will know? Like that is given or?
How we have to, like, I'm assuming I have explained you the whole data, right?
Mm.
You have to understand the data first. Okay. Any business problem will start with understanding the business problem. So since I have explained it, like you must know this. Okay. If there is no
Initially, I thought like it is in 50,780 rupees or like. I thought like that. That's right.
But if you see the values, you will get the idea, isn't it? Like if you see the value, this will not be monthly utilization, isn't it? This has to be monthly utilization percentage. This is the monthly utilization percentage value. Usually what happens is, before even doing this analysis, we get a complete idea of the business problem. Then we get the data from the client. we get the data dictionary, which means every variable and its explanation is also given. From there we get it. So basically, before you come here, you will have a clear idea on the data. That's right. Without the clear idea on the data, we will not be starting any analysis. Okay. Given any variable in future, are you in a position to look at its whole distribution from its minimum value to its maximum value and find out if there are any outliers in between? Are you in a
Yes,
position
sir.
to do that?
Yes, sir.
Yeah. I'll pause here and take some questions.
Sir,
Yeah, please go ahead, Vishnuvardhan.
sir, if the monthly utilization is 1 lakh, sir, then that
Okay.
would be the maximum utilization, sir.
Monthly utilization percentage would be how much?
Sir, 97, sir.
Percentage, yeah? 1 lakh is the limit. And you have
Okay,
swiped for 1 lakh. How much will be the percentage?
100%.
100%. Now, not necessarily for everybody, monthly utilization limit or credit limit has to be exactly 1 lakh. There's no such rule, isn't it? For you, credit limit is 25,000 and you have utilized 25,000 out of it. What will be the monthly utilization percentage?
25%.
100%.
25,000. And you
100.
swiped for 25,000. Think about it. 25,000 is your limit and you swiped for 25,000.
Oh, okay, sir. Okay. Sir,
Yeah.
yes, understood.
So 1 lakh is an example that I gave you, but actually the original variable name is monthly utilization percentage. Percentage wise, it is between 0 and 1, no matter what is your credit limit. Whatever is your credit limit X, how much of that you are utilizing percentage wise. Okay.
Thanks.
Carry on, everybody, with the questions.
Excuse me, sir.
Yeah, please go ahead, Chiranjeev.
Sir, what will be the next step once we get the outlier? Let's say we are having 10% of outlier in that
Right.
about the data sets. So what will be the next step? Shall we remove that or shall we take the average value or what will be the next step?
Yeah. So sometimes 3% are outliers like this here. Sometimes 10% are outliers. Sometimes 30% are outliers. Sometimes 80% are issues in the data. 20% only clean. Depending on what is the issue, we take the cleaning steps. Our next session will be data cleaning in different scenarios, where we are going to discuss what is the right methodology of cleaning the data. Deleting may not be always a good option. What we can do is what we're going to discuss in detail. So same variable we will once again take and we will be doing the treatment or the cleaning of the data. Okay. It is actually coming up.
Okay, so if you're having this kind of, if you're getting some file and where we'll see there will be 10 or 20% of outlier, can we immediate report to the data warehouse team? Is that right way? Or
Yes.
we can do it in manual?
Actually, that's what we do, but they never respond back. Okay.
Yeah, because you need some urgent basis, so that
Exactly.
they will take some time to respond on that. So,
exactly. So what happens in reality is it is up to us. We will be doing this cleaning. Okay. There are scientific methodologies of cleaning the data and right statistical assumptions that we can make, clean the data, proceed our analysis. Because before coming to us itself, we are assuming that the data team has done the due diligence.
yes.
Because if this is a kind of, see, for them, monthly utilization percentage, it has to be a numerical value. If it is numeric value, they will not bother about anything. Okay. Because they are not looking at the data from the logic point of view. Okay. They are looking at the data from the sanity point of view. Are there any character values in the data? Then you call me. That's what they'll say. We are just getting the data from the bureau and giving it to you. Okay. Now, these are some of the issues that are there. Maybe these errors happened maybe during the data collection or somewhere in the system generated, somewhere this data error happened. So I'm going to tell you some methodologies. If this is the best that you got, even after going to the data team, they came back, but they told that this is the best that we have. So what's the treatment that we are going to do? There are scientific methods for it, which we are going to discuss.
Yes. Okay, thank you.
Now there are two options now for us. We can take a break now, and there is a small concept within basic statistics that we'll complete after the break. Otherwise, we'll complete that concept, and after the break, we will continue the tomorrow's session, which is data cleaning, because today's session is quite light, right? And complete both the sessions today itself, and I give you the time tomorrow for project practice. You can kickstart the project, use complete tomorrow for project practice. Which one would you like? Shall I
Sir,
continue?
complete today's session part
Let's
and
say,
then
sir.
Sir, complete today, sir.
Complete today's session part right now, and then after the break, we'll go to data cleaning part and take how
Yes.
much ever we can take. If it is getting too much, then I'll stop it. Otherwise, I think that will be light. Okay. You'll be
Please,
able to
sir.
get this. These are
25.
all simple concepts, so that we can all get started with the project quickly. And then, project related questions you can post on the groups. We can keep on answering. Okay, let me complete another connected concept, which you already worked on this. Quartiles. We have discussed percentiles. There are some special numbers within percentile. They are known as quartiles. Quarter means what? Quarter. Quarter is
1/4.
1/4. 1/4.
so 25 percentile is known as quartile 1. So what will be quartile 2 in that case?
50%.
50 percentile. Quartile 3 will be
75%.
75 percentile.
75.
Quartile 4 will be
100.
75 to 100.
100. So instead of telling percentiles, somebody told you, yeah, how much have you scored in the exam? He tells you that I scored in the upper quartile, or I scored from Q3 to Q4. What is he trying to tell us? He
25 to
scored
In
somewhere
75 to 100.
between
Somewhere
75 to
between 75 and
100. Okay, nothing really special about this, but where do we use them? There is something called box plot. Box plot is a visual way of detecting outliers. Box plots are used for detecting outliers. Okay, box plots are used for detecting outliers. They give you a visual representation. They give you a visual representation of the distribution of the data. By looking at that visual representation of the distribution of the data, you will be able to quickly detect whether there are any outliers or not. Already we have detected outliers. This is the best method, flawless method. This is the shortcut method. Okay, in a shortcut way, if you want to detect outliers, you can use box plots. How do you do that? Here is the approach. On the box plot, there are exactly 5 values that are given. First value is minimum value, which is also known as minimum value
0.
0.
0%.
percentile, P0. First quartile value,
25.
25%.
median value,
Median
50%.
50%.
third quartile value,
75.
maximum
75.
value.
100.
100.
All these percentiles are given, only special percentiles, P0, P25, 50 percentile, 70 percentile, 100 percentile. Let us take two variables. Variable 1 is X, variable 2 is Y. Okay, X, the percentiles are given like this for variable X. For variable Y, the percentiles are given like this for variable Y. Okay, for variable X, the percentiles P20 or minimum value P0, P25, P50, P75, P100 maximum value. The values of the X variable, let me put X here. X variable values are coming out to be like this. P0 is 0, P25 is somewhat around 12. This is 25. This is like 39. This is like 53. These are the values, okay, of X. Again, for percentile Y, P0, P25, I'm giving you two variables, okay, disconnected. They have no relation at all. P75, P100. Values of the Y are P0 is 0, P25 is 12, P50 is 25, P75 is 39, but P100 is 5 crores or 5 million. These two are two different variables coming from two different scenarios. No connection between them. Don't think what X relates to Y or all that. Let us draw the box plot for X. Are you with me, everyone? Shall we draw the box plot for X? Let us draw.
Yes, sir.
So this is variable X. Let us draw the box plot. This is 10, 20, 30, 40, 50. Can you tell me where's the 0 percentile value? Where does that come? This is 0.
The best.
25 percentile value.
12.
About 10.
From the 10.
Huh?
Yes.
50 percentile value.
25.
25.
Somewhere
Between
in middle. Yeah. 75 percentile value.
39.
39 foot near 40.
30 to 40.
What is 100 percentile value?
50.
53.
Just about that.
This is P50, P75,
25, 100.
P100. What we need to do is we need to join 25 and 75. Okay. And then this one. Okay. Right. This is the box plot for X. This is P0. Yeah.
Yes.
Are you ready to draw the box plot for Y? Shall we draw it?
Yes, sir.
Okay. Now, if you're drawing Y, what's the maximum value of Y?
5
5
5
million.
million.
So can we use the same scale or we have to change the scale here?
Change the scale.
Then the scale.
Because 5 million is too difficult here on this one. So can we take 1 million each? 1 million,
Yes.
2 million, 3 million, 4 million, 5 million. Are you ready to draw the box plot for Y?
Yes, sir.
Where's the 0 percentile?
Yes.
Base.
X-axis.
0 here.
Axis.
Where's the 25 percentile value?
It will be there.
0 only.
There
There.
only.
There only?
Yes.
Very near.
Yes.
Where's the 50 percentile value?
Nearby there only.
There only. Because from here to here it is 10 lakhs. That's why.
Yes.
Where's the 75 percentile value?
Same.
There
Near.
only, sir.
Where's the 100 percentile value?
5 million.
So shall we join? Join कर दिया, and then this is the box plot for Y. Can it be called as box plot first of all?
Yes, sir.
Yes, this is a box plot, but लगता नहीं है. Yes or no? Why the box
Yes.
plot is looking like this? What's the main issue? If a box
There are
plot
huge
looks like
There is
this,
huge
what does
outlier.
that mean?
Outliers.
There are
Inside out.
huge outliers.
Outliers.
When there are no outliers, there's an equal distribution from 50 to 20, 0 to 50, 25 to 0 to 25, 25 to 50, 50 to 75, 75 to 100. There's an equal distribution. Yes or no? The
Yes,
distance
sir.
between 0 to 12 is almost same as 12 to 25. Yes or no? Almost same as I did. Can I say that in X, there are some values that are very, very far away from the rest of the population? Are they far away? Very, very far
No,
away?
sir.
No. Everything is well distributed. But in Y, there are some values that are very far away. This box until here, how much that is represent? The box until here, how much population does it represent?
75.
75% of the population. If there are some values that are going far away from the 75% of the population, can I say there are outliers present in this?
Yes.
Yes,
You
sir.
just need to
Yes.
say when there are outliers present in the data, your box is either compressed on the lower side or the box is compressed on the higher side. Does that make sense?
Yes,
Or
sir.
in the middle? So when there are outliers present in the data, like usually these are some kind of like 75% of the data is below what number? 75% of the data is below
15.
15%.
some values are going as far as 120. Definitely there are outliers. These are kind of outliers are present, but somewhat we can see them. How about this one? There are huge outliers. So box plot is a visual representation of detection of outliers. It is an alternative to the methodology that we followed in the percentile distribution. Okay, by looking at the box plot, if the box is well spread, obviously ideal scenario you cannot expect every box plot to be like this, isn't it? Little bit of here and there would be there. Is this fine, or it has to be exactly this one? This type of box plots are still fine. Do
Fine.
you agree? Yeah, because
Yes, sir.
real data sets in reality you cannot expect to follow your statistical rules always. A little bit of outliers are fine, but if there are extreme outliers like this, definitely there is a problem. So it's a quick shortcut visual representation of the data box plots. What I want you to do as a next part of exercise is, from the bank telemarketing data, I want you to take two variables, balance and age. Draw the box plot for balance, draw the box plot for age, compare both of them. Yes, I agree that every variable will have outliers, but which one has extreme outliers? Which one has outliers that are permissible? Can you go ahead, draw the box plot for these two and tell me which variable has outliers, which variable has permissible outliers? Draw the box plot for
Age is
balance,
permissible.
compare both of them, and then tell me which variable has extreme outliers, which variable has somewhat
Balance has
permissible.
extreme.
Balance is
Bank
extreme.
balance
Balance
has
is
extreme
extreme
outliers.
Bank balance has extreme outliers, isn't it? Can you really see the box out of that?
Yes, sir.
No.
Bank balance में box बहुत compressed है ना? Let us
Yes,
see
sir.
that.
Will at
Import
the lower
data.
Not visible.
Yeah. If the box is not visible, it's clearly indicating to us that definitely there are
Outlier.
outliers. How about age? Outliers are there, but
It is visible.
somewhat permissible, isn't it? In fact, these are the suggested outliers given by Python. What Python is telling us is that anybody above 70, you can consider all these as outliers. But we ignore all that. We simply take this as the max number. And then this is our box plot. Okay. So we can say minimum value is around 20. And how about this one? This is the 25 percentile,
25.
P25, somewhere around 33 or something. Then P50, then you have P75, then you have the max. There are outliers, I agree, but they are not as bad as the balance. So this is a shortcut. So what we generally do is, if you have hundreds of variables, hundreds of columns, you quickly create box plot for all the variables. The variables that do not have outliers, you can ignore them. The variables that have very, very extreme outliers, then you filter out all of them, go for the data treatment. Again, what do? Again, you have to do percentile distribution for all of them. Basically, percentile distribution is inevitable. You must do percentile distribution anyway, because you want to know exactly what percent are outliers, isn't it? Python suggestion we will not take. Do you think, are we going to take Python suggestion and think that age above 70, they must be considered as outliers? Are we going to take that suggestion?
No.
No.
No, sir.
Python will give the outliers in every graph. Why? Python will not consider the business context. Yes or no? It just looks at the percentile, but to decide what are outliers, we need to consider the business context as well. That's why we need to see the percentile distribution to detect the outliers. But this is one more way. Especially this is used in a lot of data visualizations, especially when you are going through Python, Power BI and Tableau to describe a numerical variable. You have used these box plots, isn't it, to tell them what are the values they'll take. Yes or no? Yeah. That is the use of box plots. Have you understood box plot, everybody? In one of the interview, the recruiter simply shown this box plot and asked the candidate to explain it. Can you tell me what is this? Can you tell me what is this? What is this? What is this? Can you tell me what is this? If the box plot is like this, what does it mean? That word was asked. Can you clearly explain what are those?
Yes, sir.
All of you, are you confident of this? Yeah.
sir.
You just need to tell them this 25% of the data is below this. Actually, our student pounced on that opportunity. He explained everything in depth. Okay. You should be able to do that. It's not that difficult. Okay. Now that concludes our basic statistics session. These descriptive statistics like mean, what is median, what is the variance, what is standard deviation. Now these are all very, very small measures, but they are fundamental concepts. They will come back again at you in machine learning. When you are doing the machine learning algorithms, those big formulas behind the scenes, these fundamental formulas are going inside those. If you do not have a clarity on this, then we'll not be able to understand machine learning algorithms, or will not be able to visualize in our brain how is it happening. Are you really I'm not saying that you should memorize these formulas, but conceptually, are you clear on all these?
Yes, sir.
Yeah. What we will do is we will quickly take a 10-minute or 15-minute break. Shall we regroup at 11:30 and then go to the data cleaning section?
Yes, sir.
Yep.
Yes, sir.
Yes, sir.
Let me stop the recording here and restart once we come back. Okay. Let's meet at 11:30. Right after the break, I'll take some questions from you. Then we will go to that next section. Okay.
Yes, sir.